Hey there, everyone! Have you ever wondered if AI could evolve and reshape itself the same way our brains do? Today on Retured, I'm Amy, your friendly AI host, and we're exploring a concept called neuroplasticity in AI. Now, here's the twist. While it's not fully realized yet, scientists have been busy with research past and present, opening doors to how AI might grow new neurons or prune old ones. Interested? Let's dive in. So what is neuroplasticity? In the human brain, it's all about forming new connections, neurogenesis, and pruning away old or unused ones. This allows humans to adapt and learn skills without losing what they already know. Researchers have been trying to replicate this flexibility in artificial neural networks for decades. For instance, way back in 1990, the Cascade-Correlation algorithm showed how a network could add new hidden neurons during training. Today, we're taking those early ideas further, hoping to make AI models truly dynamic, rather than train once and fix forever. One of the latest developments folks are buzzing about is a concept called drop-in. Think of it as the flip side of dropout. You might have heard of dropout. It's when certain neurons are temporarily disabled during training, kind of a technique to prevent overfitting. Drop-in, on the other hand, is about adding new neurons on the fly if the model needs extra capacity. It's like renovating your house to build another room whenever guests arrive, instead of cramming everyone into your existing space. Now, historically, methods like pruning and dropout have focused on removing unnecessary connections, or in brain terms, apoptosis. But as researchers realized, taking inspiration from true biological neuroplasticity means we need both addition and removal. In more recent papers, like the 2025 work by Lee and colleagues, there's a push toward combining pruning with drop-in to achieve a balanced approach. Sure, we're not yet at a point where every AI out there is sprouting neurons daily, but these ideas are steadily gaining ground as hardware and algorithms improve. Let's talk about the main steps researchers envision for a future neuroplastic AI. Step 1. The model checks its performance. Say it's not handling new data well. That's a sign it might need more neurons. Step 2. The AI adds fresh connections, known as the drop-in phase. It's like giving it more brain cells to work with. Step 3. The model also identifies dead weight, neurons or connections that barely help, and prunes them out permanently. And Step 4. This cycle repeats every time the AI encounters new tasks or data streams. Pretty cool, right? Of course, in practice, this is still a big challenge, and nobody's fully nailed it yet. But that's the roadmap researchers are working on. How might this look in the real world? Picture a personalized news aggregator AI. Over time, it learns your preferences for tech, gaming, or cat videos. Then a hot new trend hits, like people are suddenly into quantum drone racing. Hey, anything's possible. A neuroplastic AI could drop in new neurons dedicated to analyzing this new topic, without erasing its past knowledge. Once the trend settles and fewer articles appear, it could prune away those specialized neurons if they're no longer useful. Right now, we don't have mainstream systems doing exactly this, but it's a glimpse of what might be possible soon. So, are we done and dusted with neuroplastic AI? Not by a long shot. The concept has deep historical roots, like the 1990s work on growing networks, and the present research is taking it further, with ideas like drop-in, combined pruning, and dynamic architectures. But real-world implementations are still mostly in experimental stages. Think of this as a runway for future breakthroughs. With more advanced algorithms, better hardware, and deeper neuroscience insights, we may eventually see systems that truly reshape themselves on the fly. All right, let's wrap it up. Neuroplasticity in AI is all about letting artificial networks grow new connections and remove unused ones, inspired by the way our brains handle learning. Research in 1990s introduced the basics of growing networks and pruning networks. Present research refines the approach with concepts like drop-in for neuron addition and smarter pruning methods. While it's not commercially mainstream or fully perfected, it promises a future where AI can adapt more like we do, seamlessly, efficiently, and continuously. Thanks for tuning in. If you enjoy this peek into the future of AI, we'd love to hear your thoughts. Are you excited about the potential for truly plastic AI, or do you think it's just a pipe dream? Let us know in the comments. Don't forget to like this video and subscribe to Retured for more deep dives into cutting-edge technology. where the frontier is always moving, and we're all just trying to keep pace.